My name is John McKeon, and I'm the moderator of the Teradata Aprimo River community, Teradata and Aprimo's largest customer community. You can connect with us at teradataRiver2.com. Today, we'd like to welcome James Lee, expert architect at Nike. Nike, of course, everybody knows, clothing, footwear, sportswear, revenues almost $19 billion, 30,000 people employed around the world. Welcome back to the River, James.
Thank you.
James will be presenting at this year's Partners Conference on The Race Continues, Building Nike's Common Information Layer. James, this is a big issue for most people. You define it as a race. It clearly is a race. And I think a lot of what you're going to be talking about is delivering self-service BI. Tell me a little bit about the evolution, your journey toward that.
When Nike started data warehousing with Teradata in its latest incarnation, I guess it's been about 5 years now. The way the project went down was we ended up forklifting a lot of data from our BW system into Teradata. And we provided semantic models in Cognos, and we enabled our capability teams, which are aligned with our business functions, to develop their own reports. What we discovered was that while the teams were able to get the logic correct and produce the metrics they wanted, they were unable on their own to get the performance they needed to meet their SLAs. Self-service, it's not the same as self-sufficient. The teams were still dependent on a relatively small group of people within the Teradata Center of Excellence at Nike to get the performance they needed out of the data warehouse. When we looked at the architecture, what we discovered was, we provided the raw data and we provided the end results in many cases. What we didn't provide was that middle ground of building blocks that would make it so that the capability groups could be self-sufficient, so that they would have a well-stocked pantry to put together the meals they needed. And that's really what this common information layer is about, is interjecting into our architecture a layer where we've done, we've put the data rules in place. We have pre-joined some tables that are often joined. We have partitioned tables the right way, and we've aligned our data across transactions so that users could quickly put together reports that got acceptable performance.
So, James, give me some quantifiable details. How did this improve performance in the back end?
I'll just give some quick examples. Elapsed time, and we saw queries written against the old models, and those tables are still there. There still are base tables written directly against base tables versus written against tables in this common information layer. Elapsed times going from hours to minutes. Now, elapsed times are dependent on a lot of other things, but those are essentially during quiescent times of the day. CPU utilization dropped significantly. I/O dropped tremendously. Big reductions I/O based on some of these design practices. Spool utilization was roughly about the same in most cases.
Okay, James, what about increasing report development time and decreasing time to market?
So we have a number of cases where a number of major projects have gone live based on this architecture now. And these projects have gotten accolades at Nike for delivering more in a shorter amount of time than anything we've done before. And not only has it been time to market, but we have accomplished some reporting for our customer operations team that's never been done before at Nike. Looking at a customer's picture, a sales order picture across all of our transactions, purchase orders, sales orders, deliveries, and shipments. Seeing a whole slice for our customer operations team at one time was something that was just not feasible prior. It wasn't feasible in our legacy systems, and while we could put the information together in Teradata prior to this, the performance was such that it wasn't really usable in a customer operations mode. Now we're at a place where a customer operations rep can pull up information on a customer and within about a minute see a whole width of a customer's transaction for all their orders for a given month.
James, how did you deal with data reuse and still maintain data quality?
So a big part of this was data reuse. What we had before with the data we'd taken from our legacy system was a lot of redundancy in the data, a lot of potential to get different answers by taking columns from different tables. So as we built out this layer, we sort of went through the analysis and the modeling exercise of identifying the correct source for each attribute and making sure that we were taking it from the correct source. The other thing we did was we decided early on that we were going to enforce the referential integrity rules of our logical data model as we built out this layer. So when records didn't tie because key attributes were missing, foreign keys were missing, those records would drop out of the picture. And at times, that raised the eyes of the business. And they came back and said, hey, I'm missing a purchase order here. And we go back and find out that, well, there's a quality problem in the data, and we can address that upstream, get that fixed. And so we're actually using this program to drive data quality and improve data quality. From a governance standpoint, and this is another big win from a self-service standpoint, in order to expose an attribute on a certified report at Nike, that attribute has to be term aligned. It has to go through a governance process where our enterprise information management team has aligned a definition for that attribute globally across all of Nike's business functions. Well, what's happening before is in the previous model, a capability group would generate a report, and then they would use attributes that had not been term aligned, and they would have to take those attributes to the enterprise information management team and go through their process of getting those terms aligned. That was often a 3 to 4 week process and represented a substantial amount of the time to market. So the development could be done, but you couldn't release the report until this term alignment had been completed. What we did in the common information layer work was to have all those terms aligned as we built out these objects. So now anything exposed in this layer is already aligned. It's grab and go. So if the attribute's exposed in this layer, you can use it. It's already term aligned. The performance is much improved, and so we have a much faster time to market and data quality and governance improvements across the board.
Amazing. James Lee, expert architect at Nike. Come hear his session at Partners Conference. The race continues, building Nike's common information layer. James, we look forward to hearing you at Partners this year.
I'm looking forward to myself. Thank you, John.